Scientists at Berkeley Lab are igniting stars, of the virtual variety, inside computers, and their work could blow open present theories and assumptions about the universe. The program they're using, dubbed Maestro, recently ran the first 3D full star simulations of the 2 to 3 hours before a white dwarf ignites into a Type 1a supernova.
You have billions of years, you have centuries. The star explodes in 2 to 3 seconds. And there's this transition period from the centuries of simmering to the actual explosion. That's the period that we're capturing.
The team responsible for Maestro is made up of researchers from the Center for Computational Sciences and Engineering, a group within the Computational Research Division, and Michael Zingali, an astrophysicist from Stony Brook University. They explain that scientists have been avoiding simulating those last hours because of the astronomical amounts of computer power and time needed.
So no one's been able to figure out how to see the initial conditions. Basically, they've been guessing, and they'll tell you that. They've been guessing.
Critical to their success in making the simulation realistic to run is the use of a low Mach number approach in their code that allows the simulation to factor in the effects of sound waves without actually monitoring them. This makes it possible to simulate hours instead of just seconds.
Well, there's a lot going on here, so let me explain. You see a bunch of red and blue contours appearing. The red contours represent outward radial velocity. The darker the contour, the stronger the magnitude. And blue represents inward. These yellow dots of varying shades at the center represent how quickly things are burning, essentially, the nuclear energy generation rate. So, as you can see, with time, this represents the last, I'd say, half an hour of convection before the star ignites or reaches 10 to the 9th Kelvin. As you can see, as the contours darken in the center, that the reactions are proceeding more rigorously.
But why simulate white dwarfs igniting into Type 1a supernovae?
So there's something that's very special about Type 1As, and they're used as what we call standard candles.
Assuming that these supernovae are consistent candles, scientists can then figure out how bright the star is, how far away it is, and even how fast it's traveling away from the Earth. This has led to the theory that the universe is not only expanding, but that its expansion is accelerating. Trying to find those forces pushing the universe apart has led scientists to equations that describe a universe full of dark matter and dark energy, unable to be detected except through the perceived influence on what we can see.
But this is all based on the assumption that the supernovae so many years ago behaved like the supernovae now. What if the mechanism wasn't exactly the same? What if the rotation rates were different? What if the compositions were slightly different and that mattered? And the problem is we don't actually know how they blow up.
Through simulations with Maestro, the team hopes to either confirm or disprove the similarity of supernovae. It could mean the theories dominating astrophysics today have a solid foundation, or need to be rebuilt from the ground up.
We're trying to understand something very fundamental, which is how they blow up, but it has implications for the fate of the universe.
From the Computational Research Division inside Berkeley Lab, I'm Bradford Applin.